Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing one of the important problem based on the problems on change of the coordinate matrix or the coordinate vector. Okay, so that is in the basis Rn. So in the previous lecture, we discussed that the same problem only in the basis R2. So now we are going to discussing in the basis Rn. So same problems only. So now we are going to discussing 3 by 3 matrices, and we are also going to discussing field of polynomials. So whenever you get a question from the field of polynomials to find the coordinate vector, how we can solve. Okay, here question number 2 is the problem based on the field of polynomials in the method of B coordinate vectors. Okay, so therefore, so let's see the question number 1 first of all. Let B1 equal to 1 minus 3, B2 is equal to minus 2, 4, and C1 is equal to minus 7, 9, C2 is equal to minus 5, 7 are the 4 vectors, and consider the basis for R square. Consider the basis for R2 given by capital B is equal to B1, B2, and another basis capital C is equal to C1, C2. So here we have 4 vectors in the vector space R2. Here capital V is equal to R2 is the vector space, 2-dimensional Euclidean space. Okay. So in that vector space we have 4 vectors B1, B2, C1, C2. Those 4 vectors corresponding to the 2 bases. Here capital B is B1, B2 and C is C1, C2. With the help of these 4 vectors. So first of all, find the first sub question is find the change of coordinate matrix from B to C. Okay, so we have to find the coordinate matrix. You know very well, P from B to C, coordinate matrix from B to C. Next, second sub question, find the change of coordinate matrix from C to B. Same question only, from C to B we have to find out the equations. Based on this method only, in the previous lecture also we discussed one problem. That problem is depending upon the same process only. Now in the second question, in P2, okay, or P suffix 2. P suffix 2 is it is a field of quadratic polynomial. Quadratic polynomial means whenever you get any equation in the quadratic format, the set of all those types of polynomials we can consider as a one field. So this P2 is only like that only. In real numbers, R2 likewise, in polynomials P2 that is only. Okay, so find the change of coordinates matrix from the basis capital B, where vectors in that basis is vectors are polynomials. Okay, the first quadratic equation is 1 minus 2t plus t square, 3 minus 5t plus 4t square, and the third one is that 2t plus 3t square. So these are the 3 quadratic equations. To the standard basis capital C is equal to 1 comma t square. Okay, so then we have to find the B coordinate vector for the given vector or given linear equation minus 1 plus 2t, minus 1 plus 2t. So ఇక్కడ మనకు 2 ప్రాబ్లమ్స్ ఉన్నాయి. 2 ప్రాబ్లమ్స్ లో ఓవరాల్ గా మనము B coordinate vector ని ఒక దాంట్లో ఫైండ్ అవుట్ చేయాలి. The change of coordinate matrix from B to C, from C to B. So we have to find out. So one of the very important problem, listen carefully. First problem, given basis for R2 is capital B equal to B1, B2 and capital C equal to C1, C2. Here we have 2 bases, and given vector values B1 you can write B2 and C1, C2. Those values we can write from the given data as it is. Now the first sub question, here in question number 1, the first sub question is the change of coordinate matrix. To find the change of coordinate matrix from B to C. So the matrix, ఈ టోటల్ స్టేట్మెంట్ ఉంది కదా, దానికి మనం మ్యాథమెటికల్ ఈక్వేషన్ ఏంటంటే the matrix, the change of coordinate matrix from B to C we can represent in this format. P from B to C involves the C coordinate vectors of B1 and B2. Whenever you write from B to C, okay, so P is common, so from B to C or from C to B is the different for those 2 matrices. Whenever you write from B to C, okay, that means that in that matrix involves the C coordinate vectors of B1 and B2. C coordinate vectors of B1 and B2. So those are, we can write C coordinate vector of B1. C coordinate vector of B1 equal to, in the format x1 comma x2, where x1 comma x2 are the scalar. Okay, and C coordinate vector of B2 or B suffix 2 equal to y1 comma y2, y1 comma y2, where y1 comma y2 also scalars. So simply we can write this value only. We can also write this value in the linear combination format also. x1 c1 plus x2 c2. Why? Because where c1 c2 are the any two vectors, x1 x2 are the any two scalars. Don't get confused, Amma. Here x1 x2 are the scalars. c1 c2 already mentioned in the problem, they are vector. Next to this b2 of we can write in the linear combination b suffix 2 is equal to, okay, so y suffix 1 c suffix 1 plus y suffix 2 c suffix 2. We can write in this format also. ఈ linear combination నే మనం above format లో రాసుకుంటాం. Okay, this linear combination only we can write in this format. This linear combination only we can write in this format. మీకు అర్థమైందా? సో ఆ ఫార్ములాని c coordinate matrix of b1 we can write in this format. Okay, and c coordinate matrix of b2 we can write in this format. So therefore, then by the definition, okay, which definition? So according to the coordinate mapping definition, b1 we can write in the matrix format. So the definition you know very well. C coordinate matrix of x is equal to p from b to c. Okay, b coordinate matrix of small x. Okay, from this definition we can write b1. Why? Because before applying this definition we can write x as a linear combination of some vectors and scalars. Okay, for example, v1 comma x1 plus v2 comma x2 plus up to so on v suffix n comma x suffix n. Before writing this equation we can write small x as a linear combination. Same here also. Here we have b1 is in the linear combination, b2 also in the linear combination. Now those linear combinations we can write in the original definition format. Okay, so therefore b1 is equal to matrix format c1 c2, where c1 c2 are the vectors and x1 x2 are the scalars, and b2 is equal to c1 c2 and y1 y2. దీన్ని మీరు ఎక్స్పాండ్ చేశారు అనుకోండి RHS లో, అగైన్ యూ విల్ గెట్ c1 y1 plus c2 y2. మళ్ళీ మీకు లీనియర్ కాంబినేషనే వస్తుంది. జస్ట్ ఆ లీనియర్ కాంబినేషన్ ని మనం బ్యాక్ సెండ్ చేస్తున్నాం. అంటే బ్యాక్ అంటే మనం ఏమంటాం అంటే కొన్నిసార్లు మూవీస్ లో చూపిస్తుంటాం కదా, కొన్ని సీన్లు బ్యాక్ వెళ్తా ఉంటాయి. ఓకే, సో ఆ ఫార్మాట్ లో అనమాట. సో దేర్ఫోర్ now to solve both systems simultaneously, augment the coefficient matrix with b1 and b2. Here we have systems means nothing but b1 is a one linear combination, b2 is another linear combination. Those two systems, to solve those two systems simultaneously we have to apply the augment matrix for the b1 and b2, and after that row reduce we get. Finally row reduce means after applying that augmented matrix we have to convert that given obtained matrix into row reduced form. So that is, so this one is the resultantly the change of coordinate matrix from b to c. ఇక్కడ ఈ పర్టికులర్ గా ఈ వాల్యూని ఎందుకు రాసామంటే మనము సిస్టమ్ ఆఫ్ ఈక్వేషన్ అని చెప్పాము కదా పైన. ఓకే, టు సాల్వ్ ద బోత్ సిస్టమ్స్ సైమల్టేనియస్లీ అన్నారు. బోత్ సిస్టమ్స్ అంటే ఇక్కడ మనం ఏం రాసుకోవచ్చమ్మా, b1, ఓకే, సో b1 ఓవర్ c, b2 ఓవర్ c, ఇవి రెండు మనకు బోత్ సిస్టమ్స్. ఇది మనం మ్యాట్రిక్స్ ఫార్మాట్ కూడా రీప్రజెంట్ చేసుకోవచ్చు. సో అదే వాల్యూని నేను ఇక్కడ డైరెక్ట్ ఏం రాసా అంటే ద చేంజ్ ఆఫ్ కోఆర్డినేట్ మ్యాట్రిక్స్ ఫ్రమ్ బి టు సి. ఓకే, సో అది ఉంది. మీరు బ్యాక్గ్రౌండ్ లో ఇక్కడ రెడ్ కలర్ తో రాసిన వాల్యూ ఉందనుకో ఇమాజిన్ చేసుకోండి. ఓకే, సో దేర్ ఫోర్ దట్ ఈస్ ఈక్వల్ టు, సో ఆగ్మెంటెడ్ మ్యాట్రిక్స్ ఫర్ ద వెక్టార్స్. ఓకే, c1 c2 అండ్ b1 b2. సో ఇక్కడ మధ్యలో మీకు డాటెడ్ లైన్ ఉంది కదా, సో ఇట్ రిప్రజెంట్స్ దట్ ద ఆగ్మెంటెడ్ మ్యాట్రిక్స్. c1 c2 is a 1 2/2 matrix, c1 c2 is a 1 2/2 matrix, b1 b2 is a 1 2/2 matrix. అర్థమైందా? సో మీకు ఓవరాల్ గా మొత్తం మీరు దీన్ని ఎక్స్పాండ్ చేసుకుంటే మీకు ఏమొస్తుంది, 2 rows వస్తాయి, 4 columns వస్తాయి. ఓవరాల్ గా ఈ మ్యాట్రిక్స్ మీరు ఎక్స్పాండ్ చేసుకున్నారు అనుకోండి, 2 rows 4 columns ఎగ్జిస్ట్ అవుతాయి అన్నమాట. సో నౌ సబ్స్టిట్యూట్ ద కరెస్పాండింగ్ c1 c2 b1 b2 values in above augmented matrix. So if you substitute those values, you will get in this format. So therefore, the change of matrix from B to C equal to, so this one is the C1 value and this one is the C2 value, B1 value, B2 value. So substitute the corresponding values. After getting this value, order of this value is 2 rows are there, 4 columns are there. 2 by 4, it is a rectangular matrix. Now to get the solution of this matrix, okay, so converting the above matrix into reduced echelon form by row operation. Directly we are mentioning that not echelon form, reduced echelon form. Reduced echelon form means in the pivot positions we have to get the value equal to 1. Below entries, above entries of the pivot position should be equal to 0. Okay, so then you will get one identity matrix. ఇక్కడ మీకు ఏంటంటే 2 by 2 identity matrix వస్తుంది. The 2 by 2 identity matrix is row equivalent to that the inverse matrix అని చెప్పేసాం. So you can see that converting the matrix into reduced echelon form by row operations, that is R2. So here to apply that row echelon form, so first of all we have to recognize the pivot position. Here -7 is the pivot position and this total column is the first pivot column. So then this second row 9 value we have to equal to 0. So to do that process, so I am changing row 2. Why? Because that 9 is existing in the second row only. So R2 equal to 7 R2 plus 9 R1. Okay, this total row you can multiply with 7 and this total row you can multiply with 9. Resultant rows you can add, then you will get. So we are not changing row 1 amma. Row 1 you can write as it is, -7 -5 1 -2, and resultant row 2 after applying that row operations. Okay, so then you will get 0 4 -12 10. 0 4 -12 10. Why? Because so if you multiply with 9 you will get, so 9 7s are -56, 9 5s are -45, okay, 9 1s are 9 and 9 2s are -18. Okay, -2 is there. Similarly with if you multiply with 7 amma second row, you will get 7 9s are 56 and 7 7s are 49. Okay, 7 3s are 21 means -21 and 7 4s are 28. So this is the resultant matrix after multiplying the row operations. So you can add these two rows. Okay, plus 56 minus 56, here you will get 0. Why? Because we are changing row 2 amma. We are changing row 2. So that 0 you have to write in the row 2. 0. Okay, that 0 here we are writing. Next, -45 plus 49. That value is +4. Next, +9 minus 21. That is -12. -18 plus 28. -18 plus 28, that value is equal to +10. Okay, so in this format you can apply the row operations. మీకు అర్థం కావాలని ఇక్కడ రాసినది. So it is very easy only if you observe carefully. So resultantly you will get the matrix in this format only. Now this one is the pivot position, below element equal to 0. Next we have to consider the another pivot position, that is 4. Okay, so another pivot position is 4. Now divide row 2 with by 2. Okay, divide the row 2 with the integer 2, then you will get row 1 will be as it is, -7 -5 1 -2. So there 0. 4 by 2 is 2. 4 by 2 is 2. -12 by 2 is -6. 10 by 2 is 5. In this format you will get the values. After dividing with 2, again we are selecting the pivot position in the second row, that is in the second column only. So therefore this one is the pivot position. Now if you consider this value as a pivot position, there is no possibility for the below elements or below entries. So there is a possibility for the above entry to make 0. Okay, -5 is there, that -5 we have to make 0. That -5 existing in the row 1, first row. So that's why we are applying that row 1. R1 implies to do -5 equal to 0. So we multiply row 1 with 2 and row 2 with 5. Then resultantly you will get 2 rows, 2 new rows. If you add them, you will get in this format, -14 and +5 +10 -10 will become 0 and -28 +21. And row 2 we are not changing, you can write as it is, 0 2 -6 5. Okay, so now we got 2 pivot positions, okay, and we got 2 pivot columns. Then further no pivot columns. Why? Because there are only 2 rows only in each and every row. There exists one pivot position. There are only 2 rows, so we have only 2 pivot positions and only 2 pivot columns. So therefore, now it is the echelon form. Okay, this matrix is in echelon form. Now that echelon form, again by doing that row operations, we have to convert into reduced row echelon form. So to do that process, our aim is here minus 14 is there, plus 2 is there. We have to make them equal to 1 by dividing with the corresponding values. Okay, divide row 1 with minus 14, divide row 2 with by 2, then you will get in this format. So therefore, so if you divide those values in this format, you will get the values. If you divide with row 1 minus 14, 1, 0, 2 minus 3 by 2. If you divide row 2 with 2, 0, 1 minus 3, 5 by 2. Those are the resultant values. If you observe carefully, if you observe that resultant matrix carefully, left to half part of that augmented matrix, this left half part is 2 by 2 identity matrix. 2 by 2 identity matrix. Okay, this right half part of that argument matrix is our required the change of coordinate matrix from B to C. Our required the change of coordinate matrix C. Okay, so likewise in the previous lecture we discussed about that the inversible matrix theorem. There in one of the statement, that is statement B, capital A is row equivalent to that. Okay, in matrix inverse theorem, matrix inversible theorem, in matrix inversible theorem, second condition, that is statement B, shows that capital A is row equivalent to that n by n identity matrix. Capital A is row equivalent to that n by n identity matrix, where capital A is also n by n square matrix. That means in mathematical format we can write I n by n, okay, capital A inverse, capital A inverse. Whenever you apply that row equivalent condition, so left part of that augmented matrix you will get identity matrix. Right part of that you get the require the inverse matrix for capital A. Here also we got this matrix. That matrix is called the change of the coordinate matrix from B to C. That resultant matrix only. So therefore that value in the general notation we can write capital I. Okay, so that matrix we can write capital I. This matrix we can indicate with P from B to C. So therefore P from B to C is 2 minus 3 by 2 minus 3 5 by 2. So this is the our required the change of coordinate matrix from B to C. So we did nothing ikkada. So just to argument matrix apply chesam. After that row reduced echelon form like convert chesam. So where we got identity matrix, that identity matrix with the help of identity matrix, the given matrix is row equivalent. So ఈ కండిషన్ ఏమని చెప్తామంటే గివెన్ మ్యాట్రిక్స్ ఈజ్ రో ఈక్వివాలెంట్ టు 2 by 2 ఐడెంటిటీ మ్యాట్రిక్స్ అని చెప్పేస్తాం. సో ఆ RHSI లో ఉన్న హాఫ్ మ్యాట్రిక్స్ నేమ్ అని చెప్పేస్తాం అంటే అవర్ రిక్వైర్డ్ మ్యాట్రిక్స్ అని చెప్పేస్తాం. ఈ ఫార్మాట్ లో కూడా మనం ఫైండ్ అవుట్ చేయొచ్చు. హియర్ వీ డిడ్ నాట్ అప్లై ద జనరల్ ప్రొసీజర్ ఆఫ్ ద కోఆర్డినేట్ వెక్టార్. ఓకే, మనకు ఫార్ములా ఉంది కదా. వాట్ ఈస్ దట్ ఫార్ములా? ఈ ఫార్ములాని మనం ఏం యూజ్ చేయలేదు. Just by the definition only we applied the procedure. So in this format we can find the solution for the first question. Okay, so this is our required solution for the problem. The change of coordinate matrix from B to C is given by in this format only 2 minus 3 by 2 minus 3 5 by 2. That is in first question, first sub condition.